Now, in the next set of problems, we are asked to find the measure of each numbered angle. So this is a little different from what we have done in the last lesson, where we were only asked to find relationships between angles. So in the last lesson, we were asked to find out if angles were congruent or maybe supplementary to each other, but here we're actually asked to find the exact degree measure. Okay, so we've got to provide a little bit more information for each of these problems. Well, let's take a look at the first diagram. What I've done is I've extended the lines out just a bit so that it's really clear that this is line A, this is line B, and then the two horizontal lines are line C and D. That way we can kind of refer to them a little bit easier. Rather than going in order, looking at 1, 2, 3, and 4, I'm going to focus on the diagram, notice relationships between the angles, and then use those angles in any order I want to identify the degree measures of 1, 2, 3, and 4. And then at the end, I'm going to go ahead and I'm going to fill those blanks in. That way, I can do the easier ones first, and I can do them in the order I want to do them in based on the relationships that I see. So I'm going to try to take the easiest possible relationship here, which is between this angle, which is 60 degrees, and the other angle that is supplementary to it. I hope you see these two angles form a linear pair. 60 plus 2 have to add up to 180 degrees because they are a linear pair. And that immediately makes angle 2 equal to 120 degrees. Okay, so I can write measure of angle 2 is 120 degrees because I know that those are linear pairs. Doesn't matter that I didn't do it in order. Okay, now let's see, can I figure out what angles 1, 3, or 4 are? Take a moment, take a look at this diagram, try to figure out, is there enough information here to figure that out? In fact, there's more than enough information. Okay, there are many ways that we can go about figuring out the measures of angles 1, 3, and 4. Let's look at some of these ways. Let's take angle 3, and let's try to see if we have any relationships between angle 3 and the 60-degree angle, or angle 3 and angle 2. Well, angle 3 and angle 2 are both formed by the same transversal B, right? And they're both on the same side of the transversal, aren't they? So therefore, they're same side interior angles. They're supplementary. So angle 2 and angle 3 are supplementary to each other, which makes angle 3 equal to 60 degrees. We can write that in here. But was there another way we could have determined that angle 3 was equal to 60 degrees? Actually, yes, there was another way we could have seen that. Looking at the same transversal B and looking at the same two parallel lines C and D, notice, and it might be a little easier to see this if we just extend D out a bit, that the 60-degree angle and angle 3, which is also 60 degrees, it turns out, are alternate interior angles. They are on opposite sides of the transversal B, but they are both interior or between parallel lines C and D. So we could have used the alternate interior angles theorem as well. Okay, let's move on to angle 1. Can we figure out the measure of angle 1? Well, which angle does angle 1 have relationships with? Which angle does angle 1 share a transversal with? Well, angles 1 and 4 share transversal A, don't they? But we still don't know what angle 4 is. So let's look further. Well, angle 1 and angle 2 both share transversal C. Okay, C makes up one of the sides of angle 1 and angle 2. So they have a relationship. And that relationship is that when C crosses lines A and B, it creates angles here that are interior to A and B. So 1 and 2 are interior angles. They're between A and B, and they're on the same side of C, so they are same side interior angles. And same side interior angles are supplementary. So we know that angle 1 is supplementary to 120 degrees. That makes angle 1 equal to 60 degrees. We can write 60 degrees down here. And now we've got lots of ways to figure out angle 4, don't we? Because angle 4 and angle 3 are supplementary because they are also same side interior angles formed by the transversal D as it cuts across A and B. Notice 4 and 3 are interior between A and B. But also 4 and 1 are same side interior angles because they share transversal A crossing line C and D. And when that happens, we get same side, these are in the same side of A. On the right side of A, we get same side interior angles 1 and 4. So either way you look at it, 4 is supplementary to 60 degrees, so the measure of angle 4 is 120 degrees. So one of the very, very nice things about learning about parallel lines and their relationships is that you often have quite a variety of ways in which you can prove theorems, and you see that there are lots of different theorems that will all lead you to the same correct conclusion.